Hello, today I'm just going to be recording this video to clarify absolute configuration and what to do when the fourth priority isn't a wedge or a dash. So first off, when we're assigning priority, we assign it based on the heaviest atom, not electronegativity. So if I have, for example, chlorine, right, and then we have a Cl up top, a hydrogen here, a fluorine, and then finally a CH3 right here, right? This gets first priority. Is fluorine more electronegative? Yes, but we assign priority based on the heaviest atom. Then this gets second place, then this gets third place. Now, in assigning absolute configuration, we need to do this. You see how we have 1, 2, and 3? We don't really care about putting the 4. You could if you want, but it really won't help. Make sure to draw an arrow that goes from 1 to 2 to 3. So you see how I drew counterclockwise? So I'm just going to say counterclockwise, a CC. I drew counterclockwise because if I drew this doesn't represent anymore. My arrow is going from 1 to 3 to 2. So I have to make sure it goes from 1 to 2 to 3. And since it's going counterclockwise and the fourth priority is in the back, this is S. So this is a very important rule, okay? This is a very important rule. I'm just going to do it. so if we're going clockwise, and fourth priority is a dash, right? We get R. Now, if it's counterclockwise, which I'm just going to abbreviate it with C, if it's again clockwise, the same thing, I'm just going to abbreviate it with a C. But the fourth priority is in the front or a wedge, it now becomes an S. Okay? Now, if we have counterclockwise, which I'm going to abbreviate with CC, and the fourth priority is in the back, we prioritize that. I'm just going to put that's going to be an S. While if it's counterclockwise, but the fourth priority is a wedge, it becomes an R. Alright, so that's going to be very important. And that's just a way to kind of clarify it up to you, just so, like, when we assign this stuff. So, for example, in that example that I just did, if I could just get it back up again. If we have a chlorine here, fluorine here. Oh, actually, no, give me 1 second. A fluorine here. Now, this is just a different element right here. So, now we're going to assign configuration again. I have 1, I have 2, and I have 3, right? So this is going counterclockwise again. So you would think S, but our fourth priority is a wedge. So our fourth priority is a wedge. That means this is going to receive an R configuration. So this is a different element. The last one was an S. So here's the thing, though. What do you do in this scenario? Just give me 1 second just to review my notes. Okay, so what we're going to do is just to make life a little bit easier on ourselves. I'm just going to put the number. I'm not really going to care about the elements. So, suppose I'm going to have 3, 2, 1, and this is just the priorities, and then 4. Okay. Well, now we're now confused on what to do. We see that our arrow goes this way, so hold on, let me just draw it better. So again, we can see that it's going counterclockwise, CC. But our fourth priority isn't a wedge, and it also isn't a dash. So what do we really do in this scenario? This is what you do. This is what I want to call the choo-choo method train. Is that a dumb name? Absolutely. But it'll help you memorize it that much more. So what you do is this. And I'm just going to redraw it again. So, and the middle point right here is that carbon. So just to clarify that for anyone. What we're going to do is this. We're going to hold one bond constant and rotate. Now, you're like, I can't imagine 3D. It's fine. That's why I want to call it the choo-choo method train. So, I'm going to just do an example, okay? I'm going to hold this bond right here constant. I'm not going to change it. And now, I'm going to move everything one space. Like I'm going in a circle, right? I'm going to decide to go this way, all right? But, I'm going to go this way. But you could do it any other way. You could do it the reverse, okay? So, I'm going to rotate this whole thing. So, and I'm just going to draw the bonds. But now, this 2 is going to take this spot. The 1's going to take this spot, and it's going to go like this. So, I'm going to have 2 here, I'm going to have 1 here, and I'm going to have 4 here. Ah, now we see, and I'm going to draw my arrows again. So, again, we're going, hold on. So we're going counterclockwise. I said that word a lot today. So we're going counterclockwise, and our fourth priority is in the back. So therefore, we have an S configuration. So there you can have it. And suppose we rotated it another way, right? Suppose I rotated it like this. Okay. So the 2 is gonna go here, the 4 is gonna go here, and the 1's gonna go here. Again, the arrow goes from 1 to 2 to 3. Alright, we don't care about the 4 because that messes us up. So it's just from 1 to 2 to 3. And I'm just going to clarify this is a 1 right there. Right, so it's going clockwise. Yeah, it's going clockwise. But our fourth priority is a wedge. So therefore it's still S. So even though we rotated it differently, we still got the same outcome. We still got an absolute configuration of S. So that's the choo-choo method train, as I like to call it. Now, could you rotate it more than once? Absolutely. But I just wanted to do this because I kind of found it very confusing myself doing this. So I just hope that clarified. So just rotate and hold one thing constant. I could hold another bond constant. In fact, I'll show you just to prove that this method works. Just give me 1 second. So now we're not going to hold this bond constant. That wouldn't make sense. We wouldn't be getting anything. So instead, I'm going to be holding this bond constant right here. Okay? So we're going to do this. Right? And now I'm just going to put a 1 there. Okay? I'm going to move everything like this. So I'm going to have my 4 here. Yeah. I'm going to have my 4 here. Yeah, because this is a 1. This isn't changing my... Yeah, my 3 here, then my 2 here. Yep, the 2 goes. Now, as we can see, that didn't really benefit us. Our fourth priority is still not a wedge and not a dash. So we're going to rotate it one more time. So I'm just going to... Hold on, give me 1 second just to... Yeah, there we go. Maybe I could... Yeah, that's much better. So... I'm going to hold the 1 again, constant, right? And I'm going to move it, same method. So we're going to have the 2 here, we're going to have the 4 here, we're going to have 1 here, and we're going to have a 3 here, alright? Now, let's do this again. We're going to have 1 to 2 to 3. So this is going counterclockwise, and our fourth priority is in the back, or a dash. So it's S. So you see how, even though I rotate it differently, with an entirely different bond, I still got the same configuration. That's why it's called absolute configuration. It's absolute. It will not change no matter how much times you rotate it. Unless you create a new compound, the configuration of the element, of the molecule will stay the same. I hope this clarified it because I really didn't find any explanation online on how to do this. So it was very annoying for me. So yeah, I hope this helped. And if it did, just share this video with others. That's all I ask of you. Have a great rest of your day.